At 9 o'clock, a global retailer launches its biggest sale of the year. The operations dashboard is green. Every server reports healthy. But in Manila, Mumbai, and Dallas, customers cannot complete payment. Is the service available? Decide now. Yes, because the servers are running, or no, because the customer outcome is failing. Keep your answer. In the next 11 minutes, you'll learn how availability management moves beyond uptime, how to calculate the real downtime budget, where 5 nines can mislead you, and how to design a service that remains usable when something breaks. At the end, you'll diagnose this outage with 5 questions. The answer is no. In IT service management, availability means the ability of a service, or another configuration item, to perform its agreed function when required. The words agreed function and when required matter. A powered-on web server is not useful if checkout cannot charge a card. And a payroll system does not necessarily need the same 24/7 target as emergency communications. Availability management exists to ensure services deliver agreed availability that meets customer and user needs. It is not a promise that nothing will ever fail. It is a disciplined way to agree the need, design for it, measure it, report it, and improve it at a justified cost. Meet our case team. The host represents the business question. What outcome must be protected? The operations lead translates that need into architecture, monitoring, recovery, and supplier controls. The learner asks the questions many new ITSM practitioners avoid. Their fictional service, Novacart, supports customers in several time zones. Its critical outcome is not homepage loads. It is customer can authenticate, place an order, pay once, and receive confirmation. Quick check. If catalog browsing works but payment fails, is Novacart partly available or unavailable? For the agreed purchase function, it is unavailable. Availability must be defined at the service and user journey level, not chosen to flatter a component dashboard. Before choosing a percentage, write the measurement rules. Which user journey? Which users and locations? Which service hours? Which reporting period? What counts as downtime? How do latency and degraded modes count? Are planned maintenance windows included? Never hide those rules in footnotes. Suppose Novacart promises checkout 24 hours a day for a 30-day month. Its agreed service time is 43,200 minutes. If another service is required only 10 hours per business day, its denominator is different. And whether planned maintenance is excluded depends on the agreement. It is not automatically free. Without these definitions, 2 teams can report different availability for the same outage, and both can show their math. Now calculate the time-based view. Availability equals agreed service time minus downtime divided by agreed service time multiplied by 100. Novacart's target is 99.9% across that 30-day, 24/7 month. How much downtime can it absorb? About 43 minutes, 4 hours, or 43 hours? 43 minutes and 12 seconds. That is the entire monthly error budget for time-based unavailability. If checkout is down for 50 minutes, availability is 43,150 divided by 43,200, or about 99.884%. Rounded to 2 decimals, 99.88. It misses the target. Always retain enough decimal precision before deciding compliance. Here is why each extra 9 changes the engineering conversation. For a continuous 30-day month, 99% allows 7 hours and 12 minutes of downtime. 99.9 allows 43 minutes and 12 seconds. 99.99 allows about 4 minutes and 19 seconds. 5 nines allows roughly 26 seconds. Those are mathematical allowances, not automatic recommendations or universal service level terms. A cloud provider may define downtime using failed requests, zones, retries, or exclusions, not your end-to-end customer journey. So when a vendor says 4 nines, ask, 4 nines of what, measured where, over which period, and under which rules? Novacart's application tier is healthy, so why does checkout fail? Follow the transaction: domain name lookup, network edge, identity, product inventory, cart, payment gateway, fraud check, order database, notification. One required dependency can make the service unavailable. The operations lead maps the journey and circles a shared identity service used by both supposedly redundant checkout instances. That shared dependency is the hidden single point of failure. Your turn. Pause and name another likely single point. One database writer, one region, one certificate, or one supplier connection. Redundancy only helps when failure domains are truly independent. Two servers sharing one database, power feed, network path, or bad deployment are not two complete paths. Availability improves in two directions. Reliability asks how long the service operates before failing. Maintainability asks how quickly effective service can be restored. Fewer incidents protect users. Faster detection, diagnosis, failover, and repair shortens each interruption. But one percentage cannot tell the whole story. Two outages of 25 minutes and one outage of 50 minutes produce the same monthly downtime, yet they may affect different customers and business moments. A 5-minute failure during payroll cutoff or a concert ticket launch can cost more than an hour overnight. Track frequency, duration, affected users, failed transactions, critical periods, and business impact, not just a single green percentage. Who should choose the target? Not the infrastructure team alone. Start with business impact. What happens after 5 minutes, 30 minutes, or 4 hours? Which countries and time zones depend on the service? Are there legal, safety, revenue, or reputation consequences? What manual workaround exists? Then compare the risk reduction with the cost and complexity of resilience. More nines are not automatically better. An internal training portal may tolerate planned downtime. A payment authorization path during a global sale may not. Set service-level targets for critical journeys and critical periods, plus internal objectives that leave operational margin. The goal is sufficient, agreed availability, not the most expensive architecture someone can draw. Now design for the target. Caleb and the cloud mascot can demonstrate the idea with toy blocks. Two towers look redundant, but both sit on one narrow base. Remove the base and both fall. That is a common mode failure, explained without making a child the engineer. Real controls include fault isolation, load balancing, multiple instances or zones, safe retries, queues, graceful degradation, auto-scaling, tested failover, protected backups, and well-rehearsed recovery procedures. Choose controls for the actual failure modes. A second payment provider can improve resilience, but it also adds integration, security, reconciliation, and testing work. Untested redundancy is inventory, not availability. You cannot manage availability from a server ping alone. Monitor the service from the outside in. Synthetic transactions should attempt the critical journey, sign in, add an item, pass a controlled test payment, and receive confirmation. Real user monitoring shows what actual users experience across devices and regions. Logs, metrics, traces, dependency health, error rates, and latency help explain why. A health endpoint returns 200 OK, but 90% of payments time out. Green or red? Red for the agreed checkout outcome. Alert on symptoms users feel, and on leading indicators engineers can act on. Test the monitor too. A silent monitor creates false confidence. When failure occurs, availability management does not replace every other practice. Incident management restores normal service quickly. Problem management finds causes and reduces recurrence. Monitoring and event management detects meaningful changes. Capacity and performance management handles demand and speed. Change enablement controls the risk of improvements. Service continuity management prepares for disasters. Supplier management addresses external commitments. Availability management connects these efforts to the agreed availability need and the evidence of performance. That boundary matters. Saying availability owns all outages creates confusion. Better, assign clear action owners, then keep one end-to-end view of the service target, risks, dependencies, trends, and improvement plan. Now, separate high availability from disaster recovery. High availability keeps a service operating through localized component failures, often using redundancy and automated failover. Disaster recovery restores service after a major disruptive event, such as loss of a site or region. It is guided by recovery time objective, the maximum acceptable downtime, and recovery point objective, the maximum acceptable data loss measured in time. You take a backup every midnight. At 3 in the afternoon, the primary site is lost. Do you have high availability? No. You have a possible recovery source with up to 15 hours of data exposure unless other replication exists. Backups, high availability, and disaster recovery support one another, but they are not interchangeable. Back to Novacart. The 50-minute payment outage missed its 99.9 target. A useful review does not stop at add another server. The team confirms the customer journey, maps the shared identity and payment dependencies, improves external synthetic checkout tests, and sets faster detection and restoration objectives. It isolates failure domains, designs a safe degraded state that preserves carts without double charging, tests provider failover, verifies reconciliation, and runs a controlled game day. It also updates supplier commitments and reports failed transactions and affected regions alongside time-based availability. The improvement is not one shiny component. It is a tested chain from customer need through design and operations to evidence. Use this 5-question check on any service. 1. What agreed outcome must work? 2. For whom, where, and when is it required? 3. Which dependencies and single points can break that outcome? 4. How will we detect and measure failure from the user's perspective? 5. How will we prevent, restore, test, and improve at a cost the business accepts? If you answered the opening scenario, unavailable, you were right. The servers were up, but the service outcome was down. Comment with your score on the 3 rapid quizzes and name one hidden dependency in a service you use.
If you found this video helpful, don't forget to like, subscribe, and share it with others who want to learn more about IT service management. Thanks for watching, and I'll see you in the next video.